Look up at the night sky. Among the countless stars, one small red dot often catches the eye. This is Mars, our planetary neighbor. For centuries, we have looked at it with wonder, dreaming of what might be there. We have sent rovers and probes to explore its dusty, reddish surface. They have sent back pictures of a world that seems hauntingly familiar. We see vast canyons, towering volcanoes, and dried-up riverbeds that snake across the land. These features tell a story. They whisper of a time long, long ago when water flowed freely. A time when Mars was not the cold, barren desert it is today. It was a world with rivers, lakes, and perhaps even a great northern ocean. To have liquid water on its surface, Mars must have had something else. It must have had a thick blanket of air, an atmosphere much like our own. But today, the air on Mars is incredibly thin, almost a vacuum. The sky is a pale, pinkish color, and the world is locked in a deep, unforgiving freeze. So a profound and unsettling question arises. Where did all the air go? What happened to Mars to strip it of its life-giving atmosphere and turn it into a planetary ghost? Before we can understand the risks to our world, we must first understand what an atmosphere truly is. It is so much more than just the air we breathe. Think of it as a planet's invisible, life-sustaining cloak. It is a multi-layered blanket of gases held close to the planet by the constant pull of gravity. On Earth, this blanket is made mostly of nitrogen and oxygen, with small amounts of other gases like argon and carbon dioxide. This specific mix is what allows life as we know it to flourish. The oxygen fuels our bodies with every breath we take. This atmospheric blanket does many incredible things for us. It acts like a giant global greenhouse, trapping just enough of the sun's heat to keep our planet from freezing over every night. It also acts as a shield. It protects us from the sun's most harmful ultraviolet radiation, which can damage the very building blocks of life. It even protects us from a constant rain of space debris. Millions of small meteoroids enter our atmosphere every day. Most are no bigger than a grain of sand. As they streak through the air at incredible speeds, friction causes them to burn up, creating the beautiful shooting stars we sometimes see at night. When we compare Earth and Mars, we see two worlds that started with similar ingredients, but ended up on vastly different paths. One of the biggest reasons for this divergence is size. Earth is significantly larger and more massive than Mars. This greater mass gives our planet a much stronger gravitational pull. Gravity is the anchor that holds our atmosphere in place. It constantly pulls the gas molecules downward, preventing them from easily escaping into the cold, empty vacuum of space. For any planet, there is a certain speed an object must reach to break free from its gravitational grip. For Earth, this speed is about 11.2 kilometers per second. Mars, being smaller and lighter, has a weaker gravitational grip, making its atmosphere easier to strip away over time. Mars is a much smaller world, with only about 1/10 of Earth's mass. Because of this, its gravitational pull is significantly weaker, only about 38% as strong as Earth's. This weaker gravitational anchor made the Martian atmosphere inherently more vulnerable. While gravity acts as our anchor, the true secret to Earth's long-term atmospheric survival lies deep within our planet's heart. Hidden beneath the crust and mantle, Earth has a core of two parts. The immense heat flowing from the solid inner core causes the liquid outer core to churn and swirl in massive, slow-moving currents. This constant motion of conductive liquid metal acts like a colossal electric generator, or dynamo. This planetary dynamo generates a powerful, invisible force field that surrounds our entire globe, the geomagnetic field. This magnetic field extends tens of thousands of kilometers out into space. This bubble is our planet's most vital piece of armor. It serves as our primary shield against the most dangerous threat from our own star, the solar wind. We can sometimes witness the spectacular result of this cosmic defense. Near the north and south poles, the magnetic field lines dip down towards the planet's surface. Here, some of the solar wind particles can become trapped and funneled down into our upper atmosphere. As these energetic particles collide with atoms of oxygen and nitrogen, they excite them, causing them to glow in brilliant displays of moving light. This is the critical feature that Earth has and Mars lost. Evidence strongly suggests that early in its history, Mars also had a molten convecting core and a protective global magnetic field. But because Mars is a smaller planet, its internal heat dissipated much more quickly. Its core cooled and solidified, the dynamo sputtered and died, and the magnetic field vanished. With its magnetic shield gone, the Martian atmosphere was left defenseless against a persistent and powerful thief: the solar wind. The solar wind is not like the wind we feel on Earth. It's an invisible stream of charged particles, mostly protons and electrons, that are constantly boiling off the surface of the sun and racing outwards through the solar system at speeds of over 1,000,000 miles per hour. For the unprotected Mars, it became a planetary sandblaster, slowly but surely eroding its atmosphere over billions of years. As the solar wind slams into the upper layers of the Martian atmosphere, it imparts energy to the gas particles. This energetic collision can be powerful enough to knock atoms and molecules of gas right off the planet, giving them the kick they need to escape Mars's weak gravity and fly off into space forever. The MAVEN spacecraft has shown scientists exactly how this process works. This process, known as sputtering, is thought to be one of the primary ways Mars lost its air. It's a slow, methodical process, like a cosmic wind eroding a mountain, grain by grain, over geological timescales. Over the eons, these processes have stripped away the vast majority of the Martian atmosphere. Even with our powerful defenses, Earth is not entirely immune to the forces that stripped Mars bare. Our planet is locked in a constant, ongoing struggle with the sun. While our shield deflects the vast majority of this cosmic barrage, it is not a perfect, impenetrable barrier. Some particles manage to leak through, and during particularly violent solar events, the pressure on our atmospheric defenses can increase dramatically. However, perhaps the most immediate and certain threat to the stability of our atmosphere comes not from the vastness of space or the depths of the Earth, but from ourselves. Human activity is now changing the composition of our atmosphere at a rate unprecedented in geological history. The burning of fossil fuels is pumping enormous quantities of carbon dioxide and other greenhouse gases into the air. Furthermore, certain industrial pollutants can directly damage our atmospheric shield. In the 20th century, chemicals called chlorofluorocarbons, or CFCs, were found to be destroying the protective ozone layer. A global effort to ban these chemicals has allowed the ozone layer to begin healing, a rare success story that proves we can take action to protect our atmosphere. Imagine waking up one day to a world that feels subtly, yet frighteningly different. The sky, once a familiar deep blue, now appears a paler, washed-out shade. This would be the first sign that our atmosphere was beginning to vanish. Breathing would become more difficult. At first, this would only be noticeable at high altitudes, where the air is already thinner. One of the most dramatic and immediate consequences of a thinning atmosphere would be the catastrophic effect on Earth's water. The pressure of our atmosphere acts like a lid, holding our vast oceans, lakes, and rivers in a liquid state. Over time, the planet would become locked in a deep freeze. The water that wasn't lost to space would become trapped as ice, covering the land in vast glaciers and freezing the ocean solid. For the living things on Earth, the loss of our atmosphere would be an inescapable, multi-pronged catastrophe. The first to suffer would be the plants. The vibrant, noisy, and wonderfully diverse biosphere of Earth would be gone. Our planet would fall silent, becoming another ghost world in the solar system. The story of Mars is not just a fascinating piece of planetary science. It is a profound and cautionary tale written across the face of an entire world. Studying Mars allows us to look back in time, to see a potential future that Earth could face if its own protective systems were to fail. The red planet acts as a natural laboratory for atmospheric loss. So, will Earth lose its air like Mars? The comforting answer is, not anytime soon. Our planet's massive size gives us a strong gravitational grip, and our hot, churning core continues to power the magnetic shield. Our world is robust, resilient, and has proven its ability to maintain a stable environment over geological eons. We are not on the brink of having our sky stolen by the solar wind. However, this does not mean we are completely safe. The future of Earth's atmosphere, at least on a human timescale, is therefore largely in our own hands. We live on a spectacular world, a vibrant, breathing planet teeming with an almost miraculous diversity of life. All of it is made possible by that thin blue line of atmosphere visible from space. The story of Mars is a chilling reminder that such worlds are not guaranteed. It urges us to become wise stewards of our planetary home, to protect its delicate systems, and to ensure that Earth remains a living, breathing world for countless generations to come. Mars is not just a destination for our rockets, it is a destination for our minds, offering a lesson that is essential for our long-term survival as a species.